Welcome to Networks Professionals.
Welcome back, focused learners. Today, we've got an absolutely incredible explainer lined up for you. We're going to take a deep dive into the invisible conversations happening right under our noses in the digital world. Yeah, we're talking about network visibility protocols. If you've ever wondered how these massive, insanely complex webs of enterprise networks stay organized and, actually understood by the engineers who build them, well, you're in the exact right place. We're going to unpack the specific mechanism that brings order to all that chaos. Today, we're talking about the ultimate network universal translator. So let's kick things off with a massive question. How do devices from entirely different makers actually talk to each other? I mean, imagine you're at a huge international conference. Thousands of people, different companies, speaking completely different languages. It'd be total chaos, right? Unless, of course, everyone was required to wear a standardized ID badge right on their chest. A badge that clearly states their name, their company, and their specific skills, all in a universally understood format. Well, in the world of computer networking, we face that exact same multi-vendor conference scenario every single day, and we desperately need that standardized ID badge. Okay, let's dive right into this. Here is our roadmap for today's explainer. 1. The Mixed Network Challenge. 2. Introducing the Universal Standard. 3. Under the Hood at Layer 2. 4. Expanding capabilities with LLDP Med. And 5. The showdown between LLDP and CDP. Part 1. The Mixed Network Challenge. Modern networks are rarely built using equipment from just one single manufacturer. It's just a reality. You might have switches from Cisco, routers from Juniper, maybe access points from an entirely different vendor, all wired together in the exact same building. And let me tell you, this creates a massive visibility pain point. If these devices can't communicate who they are and what they're connected to, mapping out the network becomes a total nightmare. It's literally like a giant puzzle with missing pieces. But there is a hero to this story, and its name is IEEE 802.1AB. I really want you to lock this specific standard number right into your memory. 802.1AB is the official engineering standard that swoops in and solves our mixed hardware problem. Let's move to part 2 and see how this builds. Introducing the Universal Standard. So that standard gives us LLDP, which stands for Link Layer Discovery Protocol. This is a totally industry standard, vendor-neutral protocol. Its entire job, literally its whole purpose, is to be used by network devices to advertise their identity, their capabilities, and exactly who their neighbors are on a local network. And because it's vendor neutral, it honestly doesn't care if a device was manufactured by Cisco or Juniper or anyone else. It acts as that universal translator, making absolutely sure that every single piece of hardware can read everyone else's ID badge. Now, you might be wondering, why does this actually matter to us? Well, if you're managing an IT environment, LLDP is something you're going to rely on every single day. Think about the practical uses here. For troubleshooting, if a connection drops, LLDP helps you figure out the exact switch port a device was plugged into. Boom, problem isolated. For mapping network topology, it lets your software tools automatically draw out a flawless map of how everything is physically wired together. And for inventory management, it tells you exactly what devices are currently live on your network. You don't have to go manually trace dusty cables through some dark server closet. It is an absolute baseline requirement for getting critical network visibility. Part 3. Under the Hood, Layer 2. Now, what's really interesting here is the Layer 2 operation. LLDP functions exclusively at the data link layer of the OSI model, and guys, this is a total game changer. Why? Because it means LLDP works flawlessly regardless of your IP configuration. You could have a switch with a completely busted IP routing table, or maybe a device that hasn't even been assigned an IP address yet, and guess what? LLDP will still successfully advertise its identity to its neighbor. It operates purely on the physical, local link between the devices. It's just that resilient. So what exactly is written on this digital ID badge? LLDP shares its information using what are called TLV packets. That stands for type, length, and value. You can kind of think of these as structured data fields. These TLV packets contain some absolutely crucial information. They've got the system name, so you know what the device is actually called. They list the capabilities, so you know right away if it's acting as a router or a switch. They include the VLAN ID telling you what virtual network it belongs to, and they even share the management addresses, so you know exactly how to remotely log into the thing. The whole shebang is packaged up in those TLV packets and just broadcasted right out of its ports. Moving right along to Part 4, Expanding Capabilities, LLDP MED. So the core protocol is great, but it has a really specific, super powerful extension called LLDP MED. MED stands for Media Endpoint Discovery. You see, as networks evolved, we started plugging things into switches that had very unique demands, specifically voice over IP phones and power over Ethernet or PoE devices. Think about it. A standard network switch needs to know exactly how much electrical power to send down an Ethernet cable just to turn on a VoIP phone without, completely frying it. LLDP MED is the specific extension that handles that negotiation. It lets the switch and the endpoint device talk to each other to seamlessly figure out power requirements and voice-specific network policies. And that brings us to part 5, the showdown, LLDP versus CDP. Okay, comparing LLDP with CDP, which is the Cisco Discovery Protocol, brilliantly illustrates a classic network engineering trade-off. Let's look at this totally impartially. For standards, LLDP is our open IEEE 802.1ab standard, while CDP is completely proprietary to Cisco. When we talk about compatibility, LLDP gives you that beautiful, universal, multi-vendor support. CDP, on the flip side, is limited to Cisco-only environments. But check out the detail level. Because CDP is custom-built by Cisco specifically for Cisco, it can often give you much richer, deeper details and integrations, but again, only if you stay exclusively within their ecosystem. So it's that classic choice, right? The ultimate flexibility of an open standard versus the really deep integration of a closed ecosystem. So the absolutely crucial point here is knowing how to actually use this stuff in the real world. If you're operating a Cisco device and you need it to talk to your non-Cisco equipment, you got to know how to turn LLDP on. CDP is usually running by default on Cisco gear, but to fire up LLDP, you need one exact actionable command, and it's super simple: LLDP run. Literally, just by typing LLDP run into your global configuration, you instantly transform your device into a universal communicator, completely ready to map out your mixed multi-vendor network. Which brings us to a final, pretty provocative thought. As networks just keep growing more and more diverse, will proprietary protocols eventually become a thing of the past? I mean, with the massive rise of multi-vendor environments and the absolute necessity of universal standards like LLDP to keep everything visible and running smoothly, it really makes you wonder about the long-term future of closed ecosystems and network management. It is a fascinating debate, for sure, and I highly encourage you to keep exploring how these hidden protocols are shaping the digital world around us. Thank you so much for joining me today. Keep on learning, and I'll catch you in the next explainer.
Thanks for watching.